going to review really quickly, give you kind of like the recap, because your parents should have gotten an email telling you what pages to study since you missed the quiz yesterday. I'm going to tell you what you need to know really quick, and then you can pause the video and then study for it. So the quiz yesterday covered pages 167 through 171. So look at your textbook on page 167, mark anything that I tell you to mark really quick, and then pause the video and then go study. Alright, so first off, on page 167, note electrochemistry. This addresses chemical reactions that involve an electric current. Note what an oxidation reduction reaction is, or the other name for it is a redox. Remember, this is whenever you have the reaction in which electrons are transferred between atoms. So that's the type of reaction. You know it as oxidation reduction or redox. Remember, if you're losing electrons, that's oxidation. If you're gaining electrons, that's reduction. Also know which one happens in an electrochemical cell. Remember, an electrochemical cell is a device designed to produce an electrochemical reaction in an electrochemical cell. So, which one happens at the anode? That's the oxidation. Which one happens at the cathode? That's reduction. So make a note of that. Oxidation, losing electrons at the anode, reduction, gaining electrons, cathode. So make a note for that. Make a note, an electrolytic solution. This is a solution that can conduct electricity. While the cell U, an electrolytic solution is the electrolytes. So make a note for all of that. Alright, an electrolytic cell. These are types of electrochemical cells. So electrolytic cell, this is whenever you're taking electricity and you're running it through your solution in order to make it have a chemical reaction. That process is known as electrolysis. So make a note of that. So passing an electric current through an electrolytic solution to initiate a chemical reaction that would not otherwise occur, that's electrolysis. We call that an electrochemical cell the portion of the solution that is undergoing electrolysis. We call it an electrolytic cell. So keep in mind, there is a lot of words that sound very close together in this section, so be sure to study. So an electrochemical cell that produces a chemical reaction through electrolysis is a electrolytic cell. Alright, you can use an electrolytic cell though in order to produce a thin coating of metal on another object. So that process is called electroplating. So electrolytic cells can be used to form a thin coating of metal on the object by electrolysis. This process is known as electroplating. Alright, there are three other types of electrochemical cells where you're using that solution. Again, the definition of electrochemical, a device designed to produce an electrochemical reaction is an electrochemical cell. So electrolytic cell is one type of it. Alright, voltaic cell is the next one. So in this process, this is whenever the cell, when I say cell, I mean that type of solution. This type of solution, it can react and it can produce electricity. So a voltaic cell, this is whenever as a solution reacts, it can produce electricity and we can harness that. So make a note of that a result of the chemical reaction within the cells. Your book gives you the technical definition of a battery. Make a note of that. So two or more electrochemical cells connected to a single source of electricity. That is technically the definition of a battery, even though we use the word battery so loosely. Alright, one of the most widely used types of voltaic cell is the dry cell. We call it the dry cell because it's not wet like an actual liquid solution. Since it's more of a paste, we call it a dry cell. And that is an example of what the batteries actually are. Alright. Storage cell, this is whenever you're having a type of cell to where it can be recharged from electricity from an outside source. So everything is still on the inside of it, it just has to just be recharged. So this is like a rechargeable battery. A fuel cell is whenever you have to replace the fuel, so replace the reactants on the inside. It's designed to have the reactants continually replaced from an outside source. Alright, so that's all the terms you need to know. If you want to study for a minute or if you want to go back and rewatch the explanation again, you can, but do not watch the rest of this video until you're ready to take your quiz. Alright, I'm assuming if you're still here, know that that means that you're ready to take your quiz. Put your book away, put everything away. You need just a pen and a piece of paper in order to take it. So if you don't have those, go get them really quick. Pause the video and come back. So you need a pen and a piece of paper, and then label it 1 through 10. Write your name and the date at the top. If you just want to write science quiz, that's fine. I'll figure out the numbering later. Alright, so again, everything to be put away except for a pen and a piece of paper to take it. Alright, so listen carefully. Number 1, what do you call the types of reactions where you have the electrons are transferred between the atoms? What is the name for that type of reaction? When you have that transfer of electrons between the atoms, what do you call that type of reaction? Number 2. what do you call the solute in an electrolytic solution? What do you call the solute in an electrolytic solution? Number 3, what term refers to the gaining of electrons? What term refers to the gaining of the electrons? Number 4, what happens at the cathode, oxidation or reduction? So you have a 50-50 shot for this one, oxidation or reduction. All right, number 5, what do you call the process whenever you're using electricity to cause the electrochemical cell to react? So you're forcing it to react with electricity. What do we call that process? What do you call the process whenever you're forcing a chemical reaction that would not normally occur by using electricity? What do we call that process? Alright, number 6. What do you call the process whenever you're using the electrolytic cells to form a thin coating of metal on another object? What do you call the process whenever you're using the electrolytic cells to form a thin coating of metal on another object? Number 6, just making sure. What do you call the process whenever you can use the electrolytic cells to form a thin coating of metal on another object? Alright, number 7. What do you call the type of cell whenever it is producing electricity? What do you call that type of cell whenever it is producing, I think I said electrochemistry, whenever it is producing electricity? What do you call that type of electrochemical cell whenever it is producing electricity? So the reaction's already there and it's producing electricity. What do we call that? Number 8. What do you call the cells that are designed to be recharged with electricity from an outside source? What do you call the type of cells that are designed to be recharged with electricity from an outside source? Designed to be recharged with electricity from an outside source. Number 9. What do you call the type of cell that is designed to have the reactants continually replenished from an outside source? What do you call the type of cell that is designed to have the reactants continually replenished from an outside source? Then number 10, what is the most common type of voltaic cell? One of the most widely used types of voltaic cell. What do we call that? One of the most widely used type of voltaic cell. If you need anything repeated, go back and watch that particular portion of the video. Don't go back too far though, you don't want to accidentally hit my review. So if you're done, go ahead and put that off to the side. Don't forget to give it to your parents to send me a photo of it as fast as possible. I would greatly appreciate it. Alright, so the recap over the lesson yesterday over what we talked about, super quick for it, is we went over organic chemistry. So we'll review more in class, so I'm going to skip that review. I'm just going to talk about, okay, what are we going to talk about, what we talked about yesterday specifically. We talked about the fullerenes, or the buckyballs. That's what this is a picture of. It looks basically like a soccer ball. It has 60 carbon atoms all joined up together, so make a note for that one. So 60 carbon atoms all joined up together, they're known as the fullerenes. Sometimes they're just nicknamed just buckyballs, so make a note for that as well. Read through it though, because we read over it yesterday, we talked about it, just make a note of it. Alright, substituted hydrocarbon. A substituted hydrocarbon is like a regular hydrocarbon, but something is weird about it. So remember, a hydrocarbon is just made up of carbon and hydrogen. So a substituted hydrocarbon is whenever something is changed about it. I compared it yesterday to a substitute teacher, where they're still a teacher, but it's not your normal teacher. Something is different about it. We call the part that gets changed the functional group. So instead of having hydrogen there, they might have something else bonded to it. So the functional group, that's the part that's getting pulled off and replaced with something else. So that's what is replaced. So make a note of what a substituted hydrocarbon is. Make a note of what a functional group is. Alright, the first one is the haloalkanes. Alright, remember a halogen is from group 17 of the periodic table. It could be fluorine, it could be chlorine, it could be iodine. So those are all examples of a halogen. Let me get my mouse real quick. So these are all examples of a halogen. So you can notice in this picture, instead of having an H here, it has a Cl. So this one is chloromethane. We put kind of a shorthand version of the name of the element in the front. And then this is chlorine, this is chloro, and then methane. Because remember, the aim refers to single bonds, the meth refers to there's one, still not drugs. So chloromethane. This one, it has iodine up here. So it's iodomethane, because it has iodine. This one has 4 chlorines swapped out for it. Your book points this out as well, that we put a prefix in front of them to say how many have been swapped out. So instead of just calling it just chloromethane, we call that particular one tetrachloro, because there's 4 chlorines methane. So because there's 4 chlorines swapped around for it. So those are the haloalkanes and the examples for it. Again, we'll review a little bit more in class. I'm just giving you just the basics for it. So make a note. A haloalkane, that's whenever a halogen has replaced a regular H. Alright, the next major group is the alcohols. The alcohols, instead of having the H there, they have an OH. Now, typically we call this hydroxide. Whenever it's used like this in the hydrocarbons, we call it the hydroxyl group, so it's a little bit different. So instead of calling this one methane, because remember, single bonds, that refers to one, so instead of calling it methane, the ending gets changed to ol. So this one would be methyl as an example for it. If you were to use 2 carbons, I'm not going to draw all the H's, but if you were to draw it like that, so this one has 2 carbons, it would be ethyl, excuse me, it would be ethan, because it would be ethane normally for it, so ethanol, with the idea of it's still 2 carbons, but the ending gets changed because of the OH. Methanol, as a side note, this one is also known as wood alcohol. This is one reason why the alcohols, they're characterized by that OH, not just with the idea of like liquor or wine. So just make a note for that. Alright, so the next major one is the carboxylic acids. So the carboxylic acids, instead of having the OH there, they have a C, and then O, and then OH. Sometimes your book draws it as COOH like this, telling you that this root is added onto your hydrocarbon. So K is how we sometimes say it, so that way it's a little bit harder to pronounce, but it's COOH, but we'll just say that it has the K or the K functional group added onto it. We can't say Ku because that's something else, so they try to make the H sound down at the end for it. So you notice it has a double bond up here, and then it has the single bonds down here for it. So their name gets changed to it, their ending gets changed to oic acid. So for this one, because there's 2 C's, so again, F refers to 2. So this one becomes let me slow down and try to pronounce it correctly instead of going too quick. So ethanic acid or acetic acid is how some people say it as well. So instead of saying ethane, ethanic acid, so just make a note for that one for it, that it has the 2 C's as a double bond and then the OH for it. Let's see, I think that's it for it. Your book points out they typically have very pungent odors, so make a note for that. So ethanoic is how I've always heard it, as how I've always heard it pronounced. So make a note for that, so ethanoic acid. Alright, so that's with the carboxylic acids. Esters are kind of similar, but instead of having the H, they'll form up the rest of the carbon chain. So they'll re-hook up back to carbon and then keep going in some cases. So that's where this one, we say it has the Ku functional group. We give it the long oo sound as oo in book. So we'll say that it makes the Ku functional group for it. So make a note for that. This is an ester. These characteristically have fruity flavors for it, so floral or fruity flavors. So your book gives you the example of methylbuanate. Now this one, if it had just the OH down here with the carbonic acid, this one would be known as butanoic acid or butanoic acid, but I believe it's pronounced butanoic acid. I believe is how I always hear it pronounced. So for this one, they would drop the H and then keep add on another C. So that way the name gets changed to methyl, because remember, there's only 1 carbon down here. So methyl bu, because remember that refers to the idea of there's 4 carbons. So methyl bu butanoate, I believe is how most people say it. So butanoate, I believe is how you're supposed to say it. So just make a note for that. So butanoate. Alright. Sorry, I said it as a carboxylic acid one. So methyl butanoate. Alright, so that's it for the esters. Your book gives you another one down here. This one is an example of the oil of wintergreen. So if you eat spearmint gum, that's typically the oil that is associated with it. Alright, your book has a wonderful chart at the top of page 178 with all the different names, all the different types, and the different examples for them and how to name them. It's a fantastic chart. I don't have a copy of that chart. I would start that chart though with all the information about the hydrocarbons all in one spot, and it's amazing and fantastic. We'll use this to review one today, but I reviewed a lot of the students yesterday just going over it to make sure that they understood what they were doing. Alright, so your book points out a soap is a salt containing a carboxylate ion and an alkali metal. The main important parts of it though is that you have a polar end and a non-polar end. Now remember, with the idea of light dissolved light, what does that mean? It has to do with the idea of polar will only dissolve in polar and non-polar will dissolve in non-polar. So if you have a drop of oil, now the oil will not be attracted to the water. This is why trying to get oil out of a pan with just water is a pain. But if you use a soap molecule, the non-polar end will stick on the inside of the soap and the polar end will stick out. So because the polar end is sticking out, the water can basically grab it as it's going by because it's attracted to that polar end and it can help the oil wash away. Sometimes if you let a pan soak in oil, it's so much, soak in soap. It is so much easier to get the oil removed out of it. So, your book has kind of like a creepy picture at the top of the page showing you what oil droplets look like with the idea of them having the soap stabbed into them. If that helps you to just think of it that way, that's fine. The book points out with hard water, this contains water containing ions of iron, magnesium, or calcium. This one, these are whenever it can react typically with the soap. So because of that, it makes kind of like this scum on the inside of it, or kind of like this insoluble, kind of like, it looks kind of like calcium or whitish kind of chalk stuff. We don't like that, so technically the detergents today, we call them soap, but technically they are detergents, so they don't do that with the hard water. So a detergent is an organic compound similar to soaps, but capable of cleaning even in hard water, so we don't get that kind of chalky residue. Alright, we didn't quite make it to polymers yesterday, so I'll finish talking about them today in the class. So I emailed your parents the homework, so make sure that you do that homework as well for them. I can look it up really quick. I don't think I marked it down. Let me find it really quick for you. Let's see. It was to read pages 181 to 183, and then answer on page 192, the section review 8.4, questions 1 through 3. Try to have that done before class. Alright, so that's a brief recap. We're going to review in class today, so make sure you go watch this video and then watch the review in class. We're going to help you kind of see, okay, this is what's happening. Alright, so I hope you feel better, Brecken, or I hope you're having a great week, and hopefully I will see you after Thanksgiving. Bye!